Dear friends, this is chapter rotational motion which we are going to revise in fast track mode. Very first point is center of mass. If two particles of masses m1 and m2 are lying on single line, suppose x-axis, then the position vector of their center of mass will have this formula. Now, the trick for CET is if center of mass divides masses in the inverse ratio, then we can apply the shortcut formula for this inverse relationship. So, mass 1 is related to its distance from center of mass. Mass 2 is related to its distance from center of mass. For example, I have taken two molecules or atoms, carbon and oxygen. These atoms are 1.02 angstrom apart. If mass of carbon is 14 gram and mass of oxygen is 16 gram, we have to find the position of their center of mass. So in this type of question, it will be asked you from where you have to find the center of mass. So suppose in the present question, it is asked to find the center of mass from oxygen atom. So I have taken mass of carbon upon mass of oxygen as distance of center of mass from oxygen atom. See this inverse relation, and then put the values and find out the value of x, which is the location of center of mass from oxygen atom. In the similar way, we can relate velocity vector with the velocity of each particle divided by the total mass. In the same manner, we can have acceleration vector with multiplication of mass with each acceleration and divided by total mass. So, it is very easy to relate all masses with their respective parameters. So, we can have by Newton's second law that acceleration is equal to external force divided by mass. Now, the law of conservation comes if external force is 0, means बॉडी पर बाहर से कोई भी फोर्सेस नहीं लगाए जाते तो बॉडी में एक्सेलरेशन नहीं होगा and it will be moving with the constant velocity, which further leads to very important law in physics, which is law of conservation of linear momentum. So if external force is 0, the linear momentum, that is the product of mass and velocity, will remain constant. For example, we have done cases of gun and bullet where the velocity of bullet is called as muzzle velocity and the reverse velocity of gun is called as recoil velocity. Similarly, in the case of rocket propulsion, in the case of a person jumping from a boat on the river shore. These all are the cases of conservation of linear momentum. Next, we are taking again a vector quantity, which is the moment of force, or sometimes conveniently called as couple or torque. This is the cross product of force into momentum arm. So this may be in the vector form r cross f, which can be found with the help of a determinant of the order 2 by 2 or 3 by 3. Or more conveniently, we can find torque equals to I alpha, that is the product of moment of inertia and angular acceleration. Now alpha may take various expressions such as omega 2 minus omega 1 by t or d omega by t depending on the problem. Next is moment of inertia. So the word only inertia refers to this situation where we are considering two masses 5 gram and 5 kilogram. If I ask you a question, which mass is easy to move or if they are in the motion state, then which mass is easy to stop? Certainly, even a child will give the answer for 5 gram. Okay, so this property of both the masses by which they resist any change in the translatory motion is called as only inertia. But if these particles, when converted in the circular form, now I don't know whether one is a disc and the second is a ring, because till now the question does not give us any detail. But now I again ask you a question. If both the masses are rotating or rolling on the surface, if both the masses are rotating or rolling on the surface, then which mass is easy to stop? Now, with the help of this previous comparison, maybe your answer is 5 gram. But students, don't take this answer for granted, as over here the dimensions, that is radius, as well as the shape is also important. So without giving all the details, we cannot predict the answer. Now in the last of this discussion, I have given the table of moment of inertia. Moment of inertia sometimes is taking common formula as mk square, where k is the radius of gyration. So it is defined as the distance between the axis of rotation and a point at which the whole mass of the body is supposed to be concentrated at the time of rotation, and its expression will be square root of I upon m. But if length of a rod is given, or the radius of circular body is given, or sphere is given, then the formula of I may be taking different values according to the axis of rotation given. For example, when axis of rotation in a rod passes through the center, then this x will be 1 by 12. But when axis of rotation is passing through one end, then this formula will be I equals to ml square by 3. So the value of x will be 1 by 3. Now suppose we are taking this formula. In the case of disk, x equal to half. In the case of ring, x equal to 1. In the case of solid sphere, x equal to 2 by 5. And in the case of hollow sphere, x equal to 2 by 3. So these formula for moment of inertia in terms of L or in terms of R may take different values. Next comes angular momentum. Now this parameter is again valid when a body is rotating with angular velocity omega. So it is represented again in the form of cross product. So to find angular momentum, we have to again take the support of a determinant of the order 3 by 3, and as we all know how to solve the determinant. So L equals to, in magnitude wise, mvr or mr square omega. So putting dimensionally mr square as moment of inertia, so we get value of angular momentum, and value of I may be put as mk square. It will be deciding upon the given parameters in the question, and value of I in terms of L or R will be depending on the body as well as on the axis of rotation using perpendicular axis and parallel axis in the determination of moment of inertia. Next term is to find rate of change of angular momentum, as we can relate rate of change of angular momentum. So putting L equals to I omega. Now I is constant, so taking it outside. So this will be I into d omega by dt. Now d omega by dt is the angular acceleration. So the rate of change of angular momentum will be expressed as torque. So therefore torque equals to I alpha, and torque is also equal to the rate of change of angular momentum. So this is very important question for CET, as angular momentum of a body changes from 4L0 to L0 in 3 seconds. Find torque. So torque equals to L2 minus L1 by T, as it was dl by dt. So putting the values, we get answer as L0. Now the unit of torque is force into distance, so Newton meter, or it may be joule, as it is homogeneous to work done. Now next we are taking very important law in physics in rotational motion, which is the conservation of angular momentum. बहुत ही ट्रिकी वे में लेना है आपको इसको. If alpha equals to 0 means external torque equal to 0, सिर्फ तभी लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम होल्ड करेगा जब बॉडी पर कोई भी एक्सटर्नल टॉर्क नहीं लग रहा. सो फॉर दिस वी कैन टेक दैट L इक्वल्स टू कॉन्स्टेंट. तो L का फॉर्मूला लिया. आपको बहुत ही लॉजिकल वे में लेना है ये टॉपिक. नो आई के प्लेस पर आपने पुट किया mr². अब आपको चेक करना होगा अकॉर्डिंग टू द गिवन सिचुएशन कि क्या I बढ़ता है या फिर I कम होता है. अगर I बढ़ता है तो बिकॉज I एंड ओमेगा आर इनवर्सली प्रोपोर्शनल, तो इफ I इंक्रीजेस पेयरिंग विल बी ओमेगा डिक्रीजेस. इफ ओमेगा डिक्रीजेस frequency decreases, and on the contrary if I decreases then omega will increases, and if omega will increase then frequency will also increase. And now frequency equals to 1 upon time period, we may take r² upon t equal to constant. So I have taken a question for reference. If earth shrinks to 1 by 4 in its radius without changing its mass, मास चेंज नहीं होता, तो जो भी आपके पास में आए होगा उसमें से आप मास को कैंसिल कर देंगे बिकॉज मास रिमेन्स कांस्टेंट. तो फाइंड द न्यू ड्यूरेशन ऑफ डे. मतलब दिस क्वेश्चन इज रिलेटेड टू द टाइम पीरियड ऑफ स्पिन ऑफ अर्थ अबाउट इट्स ओन एक्सिस. सो बिकॉज टॉर्क 0 है तो L कांस्टेंट आ गया. तो दिस इज I इंटू ओमेगा इक्वल टू कॉन्स्टेंट. अब इसमें से कॉन्स्टेंट क्या क्या है? मास 2/5 2 पाई. So we have got this relationship as mass is constant. So we have got r² upon t is equal to constant. Therefore, for two cases of earth, we can put as r1² upon t1 is equal to r2² upon t2. So cross multiplying. So t2 is equal to r2² upon r1² into t1. So cross multiplication में आप mistakes ना करें and avoid this step. You can directly put the values in this step to save the time. As in CET, each question is needed to solve in 54 seconds, completing with bubbling at the circle. So we get T2 equals to 3/2 R. So definitely the duration of day is decreasing, hence frequency will increase. So the speed of earth will be very fast as compared to the previous case. In next example, we are taking a ballet dancer who folds his arm. So find change in the speed. As by folding the arm, radius of gyration decreases, hence moment of inertia decreases because I is equal to mk². So omega increases as the product of I and omega was constant. So if omega increases, frequency increases, and hence the speed will increase. Now in next case, if polar ice caps of earth melt, Now for reference, we have taken polar ice caps at these places, North Pole and South Pole. अब जैसे ही ये बर्फ़ मेल्ट होगी तो वो वाटर के फॉर्म में ड्यू टू अर्थ्स ग्रेविटेशन अर्थ के सरफेस पर ही फैल जाएगी, बिकॉज सेंटर इज अट्रैक्टिंग ईच एंड एवरी बॉडी टुवर्ड्स इट. So the distribution of mass is increasing about the all surface. So K, that is radius of gyration, increases, moment of inertia increases. Now I is inversely proportional to omega, so omega decreases, hence frequency decreases, so speed decreases, and as frequency and time period are inversely proportional, so time period increases. Hence, new time period will be more than 24 hours. So, you will be getting more time for sleeping and more time for studying. Next case is, this is the comparison between the parameters of translatory motion and rotatory motion. So, first is S. Displacement is comparable to the angular displacement. Velocity v is comparable to angular velocity. Acceleration a is comparable to alpha. And now we can have equations of motion which are called as kinematical equations. These are three equations. So these are three equations replacing v by omega, u by omega 0, acceleration by alpha, and the displacement by the angular displacement. Now, in translatory motion, inertia is comparable with mass. In rotatory motion, moment of inertia is comparable with mass as well as the distribution of mass about axis of rotation. Linear momentum P is related to angular momentum. Force is related to torque. And kinetic energy in translatory motion is comparable to the rotational kinetic energy half I omega square, where remember that mass was replaced by I and V was replaced by omega. So no need to learn all these formulae of rotatory motion. Then work done is force into displacement. Work done over here, force is replaced by torque and displacement is replaced by angular displacement. Power is Fv, where F is replaced by torque, V is replaced by omega. Now total energy is P square upon 2m. Total energy is L square upon 2m. Next is comparison between this table we have covered. Now by changing shape of the body, we can have different moment of inertia because radius of gyration is changing. For your convenience, I have taken example of a square where four masses are connected A, B, C, D. When we are taking axis of rotation as CD, the moment of inertia of these two particles will be 0, but the moment of inertia of A and B will be giving the moment of inertia of the system. In second case, when axis of rotation is passing through one of the diagonal, the moment of inertia of B and D will be 0, but the moment of inertia of A and C will be giving us the formula and answer as in the form of moment of inertia of A and C. Now rotational kinetic energy is half I omega square. Hence we have found rolling kinetic energy. This is a shortcut. Suppose you are find the translational upon rotational. तो translational के सामने आप लेते हैं r square and rotational के सामने आप लेते हैं k square. In the short trick you may find the ratio asked in the question. So I have given this example. These are mostly asked in CET. Now this is the body rolled on an inclined plane. If the body is giving only in the slipping condition, then just apply the kinematical equation. If the body rolls without slip, then you may take these equations for acceleration and for velocity. Put the value of theta over here. Next is moment of inertia of different bodies. The table is also given in your textbooks, but still you may take the screenshots. Similarly, we have found the radius of gyration in each case. The PDF is also attached in the discussion, so you may download it. Thank you for watching. Happy learning and best wishes.